Hello, Algebra 2 students, and welcome back to Lesson 2-3. We're going to go through Part 2 of the lesson today, starting off with Example 4. So we have a problem here where Marco hits a golf ball into the air from the third level of a driving range, and that level is 48 feet high. So this function that they're calling h of t gives the height h in feet of the golf ball t seconds after it is hit into the air. And then we're asked to figure out when will the ball hit the ground. So again, this function represents all of the different heights that the ball will reach over a certain amount of time, which is t, in seconds. So our coordinates, the x values represent time, right, which again is represented by the variable t, and the y values are all of the heights. So when we're asked when will the ball hit the ground, that's when does h equal 0, okay, or h of t. And remember, h of t represents y, right, which are all the different heights. So we can solve this problem by setting h of t equal to 0 and taking our function negative 16t squared plus 32t plus 48 and setting it equal to 0. So each of these numbers are divisible by 16. So I'm going to factor that 16 out, actually a negative 16. I like keeping the squared term positive. So that'll give us a minus 2t and a minus 3. Okay, so let's see. Now, this negative 16, that does not affect our solutions. Okay, when you pull out a constant, you can disregard that. So I'm just going to factor the t squared minus 2t minus 3. So my factors are 3 and 2, and I want the 3 negative. Did I say 3 and 2? 3 and 1, sorry. I want the 3 to be negative because then my inners are minus 3t, my outers are a plus 1t, and that gives me the negative 2t for the term in the middle. So if I set each of these factors equal to 0, I would get that t is equal to a positive 3 and t is equal to a negative 1. Now for applications like this, you have to think about what makes sense here. Right? So when will the ball hit the ground? It's impossible to have a negative time. Okay, so this solution does not make sense. So our only solution is t equal to 3, which means that the ball will hit the ground in 3 seconds. Okay, let's move on to example 5. In example 5, we're asked to identify the intervals on which this function is positive. Okay, do you remember our positive and negative intervals? This goes way back to the very beginning in topic 1, when we talked about where is the graph positive, where is it negative. So remember, these are described by x values. So remember, where the graph changes from positive to negative is along the x-axis. Right? The points on the x-axis are the x-intercepts, or the points that we call zeros. Right? They're called zeros because the y value is 0. So that's the dividing line. Right? The x-axis is the dividing line from where it goes from positive to negative or negative to positive. So what we're going to do first is find the zeros, right? Solve this equation. This looks just like our last problem, and it is. It's exactly the same trinomial. So again, it's x minus 3 x plus 1. So our two x-intercepts, or zeros, are 3 and -1. Now, I also know something else about this parabola. It makes a difference whether if this is opening downward or if it's opening upward. Which way does this function, the graph of this function, open? If you said upward, you're correct, right? Remember, we can determine that by the sign of the coefficient of the x squared term. So since this is a positive 1, a is positive, it's going to be opening upward. So the key things that I need to know, again, are these x-intercepts and whether if the graph is opening upward or downward. Since it's opening upward, my positive intervals, remember, are above the x-axis, so it's these two intervals. This was my x-intercept of -1, and this is my x-intercept of +3. So the function is positive over the interval. We're going all the way to the left. We're describing this again by x values. So all the way to the left is -∞, on up to this x-intercept, which is -1. And remember, we always use parentheses. Okay, the other interval starts at 3 and keeps on going to the right. So it's from 3 to infinity. Now, if we had been asked where is the function negative, that would have been just the one interval between -1 and 3. Okay, example 6. Here we're asked to write an equation of a parabola with these x-intercepts, right? -2, 0 and -1, 0. And the parabola passes through this point, -3, 20. So for this type of problem, we're going to use this form. And we're going to have that a value. If you remember, in the past, we did problems where we used our vertex form. We're not going to do that here because we're given x-intercepts. Okay, so the x-intercepts we represent by, we'll use an x minus p and an x minus q. And that's where p and q are x-intercepts. So if you remember me saying in one of the last videos that at some point you're going to do the reverse. You're going to be told what the x-intercepts are, and you're going to work backward to get the equation of the parabola. This is that type of example. So we're taking our x-intercepts, putting them back into factored form. So if the first one is -2, x minus a -2 becomes x plus 2. Okay, or think about it this way: the factor that gave us an x-intercept of -2, or a solution of -2, would be the factor x plus 2. The other one is -1, so that factor would be x plus 1 for the same reason. Okay, now the a and the y part, this point that the graph passes through gives us an xy coordinate. So I can plug, just like we did in the past in other problems where we use the other forms, I can plug -3 in for x and 20 for y, and that'll give me enough to solve for a. So y is 20. I'm going to replace both of these x's with the -3. And then I just have to calculate inside the parentheses first. So that's -1 and -2. So that gives me a +2 times a So A is equal to 10. So the final form is 10 times, I can rewrite these two factors again, x plus 2, or you can think of it as just plugging back into this form. And if you're asked to write it in standard form, then I would square this out first, right? Multiply the two factors together, so I get x squared. My inners give me a 2x, my outers give me a 1x, so that's a 3x in the middle, and 2 times 1 gives me 2, and then my final answer would be 10x squared plus 30x plus 20. So there's the quadratic function that has the two x-intercepts of -2, 0 and -1, 0, and it also passes through this point, -3, 20. And you could verify that by plugging those values in and checking to see if it makes sense. Okay, which actually we could do that. Let's see if our point that it passes through makes sense. So I'm going to plug 20 in for y, and -3 in for the x's. Okay, so this right now is a question mark. -3 squared, that's a terrible looking 3, but that's a -3 squared is 9, so that's 90. Minus 90 plus 20, and that does equal 20, so it makes sense. And you could plug in the x-intercepts just as easily and check those as well. Okay, so our concept summary for the factored form of a quadratic function. So this form, ax squared plus bx plus c, can be written as a times, again, the two factors, right? This is where p and q are the zeros, so x minus p, x minus q. The x-intercepts of the graph correspond to the zeros, so remember, same name. We can call them zeros, we can call them x-intercepts, we can call them solutions. Okay, the two zeros denote 3 intervals of x values, so by that they mean the interval where it's positive, the interval where it's negative, and then the interval again where it's positive. Remember, if it were a downward opening parabola, let's say this is the x-axis, then there could be 2 intervals where it's negative and 1 interval where it's positive. So it depends on which way the graph is opening, if it's an upward U or a downward U. So here's an example with this function, okay, in factored form. It's 2x plus 7, x minus 2. That makes the zeros, remember it's opposite signs, so -7 over 2, and +2 from this factor. So since it's opening upward, because the a value is positive, the intervals where it's positive go from -∞ to -7 over 2. Okay, we're not going to do inequality form, we're going to use intervals. So -∞ to -7 over 2, and from 2 to infinity. And where it's negative is in between, so that can be summed up with a single interval from -7 over 2 to 2. So that concludes our lesson for section 2-3. I hope you enjoyed it, and I hope you have a good day.